Let's kick things off with a weirdly specific but actually foundational choice. In this approach, everything starts with a right-angled spherical triangle. Not just any triangle, but one where all three angles are 90 degrees. That's kind of wild, isn't it?
Yeah, it's surprisingly elegant. By picking that triangle and saying, its area equals 1, you basically lock in the entire geometry's scale. The radius of the sphere isn't just some random number anymore. It's fixed by that choice. The triangle becomes the quantum, the basic unit of curvature.
I love that it's not just an abstract decision, either. Once you normalize the area, you can actually calculate the radius. R equals the square root of 2 over pi. That's not an arbitrary guess, but a tightly anchored starting point for the whole system.
Absolutely. And it means every other measurement angles, distances, even time in a sense gets calibrated off this unit. Geometry doesn't just float aimlessly, it's anchored by this single right-angled triangle.
That grounding in geometry actually sets us up for the next leap, quantum mechanics itself. It's fascinating how both Heisenberg's matrix formulation and Schrödinger's wave approach end up mirroring each other across this geometric baseline.
What's so cool is they look totally different. One's all about matrices, switching states in space, the other's about waves spinning in time, but under the hood, both are encoding the same thing, this entropy 1 symmetry. Both tell us that geometry chooses its fundamental unit, and time decides how things scale or evolve.
That actually reminds me of that qubit caption from the project. The matrix and the wave are like two sides of the same coin, reflecting off this one unit of curvature. There's something deeply unifying about that, almost poetic.
It's one of those rare cases where two totally different mathematical languages turn out to be saying exactly the same thing, just from different perspectives. The symmetry isn't just a coincidence, it's enforced by the way geometry's set up.
Let's dig into what happens when the system isn't perfectly tidy, though. Even with this beautiful setup, there's still a tiny leftover, the difference between pi and e. That's the famous pi minus e residue.
It's such a subtle but relentless mismatch. No matter how cleverly you build the lattice, especially when you use primes to index its nodes, there's always this sliver of error that can't be erased. The system's symmetry engine tries to keep everything balanced, but that residue keeps peeking through.
What fascinates me is that the lattice doesn't just ignore it. Instead, it has a mechanism for shedding that error. This is where G-free energy comes in. The lattice essentially releases the residue as a kind of energy, almost like a pressure valve for geometry.
And it's not just a metaphorical quirk. That release is interpreted as quantized gravitational radiation. The pi minus e graviton signature, as they call it, is the physical pulse of the lattice correcting its own imbalance.
It's one thing to talk about these ideas, but the diagrams from the project really help make it concrete. That spherical wedge, the modular quantum unit, shows how the system anchors itself in both geometry and symmetry.
Last time I looked at that diagram, what jumped out at me was how even the smallest region, the wedge labeled 1/2, holds a modular quantum of area. The rotation symmetry around the vertical axis makes it feel like the entire lattice is breathing, shedding residue as it goes.
Totally. And that modular propagation across the pi minus e boundary? The recursion between prime-indexed nodes, amplified by those exponential vectors, gives you this sense of error correction, built right into the fabric of space.
And when you see the symbolic 2 light-years labeled as a scale, it really drives home that this isn't just math on a chalkboard. It describes how curvature and geometric error ripple across the universe itself.
Bringing it all together, the thesis is kind of mind-blowing. The universe is this recursive lattice that sustains itself by constantly resolving the tiniest difference between geometry and arithmetic.
That's what I find so compelling. It's not that the universe is ever perfectly balanced, it's always just a hair's breadth away, endlessly adjusting, releasing those quantized pulses to keep itself going. The mismatch isn't a flaw, it's the engine.
Honestly, that perspective changes how I think about everything from quantum mechanics to gravity. The universe isn't a finished product. It's a living process, always in the act of reconciling itself.
And every time that infinitesimal pi minus e residue is shed, it's a little burst of creativity from the lattice, an echo of geometry choosing and time enforcing the next step. There's something almost poetic and definitely profound in that view.